Assalamualaikum and greetings. I'm Uida Suhaili, Country Lead for Brunei NAPC project. NAPC is an ASEAN IVO 2018 project focusing on the mitigation of peatland forest fire through the use of Internet of Things. Peat fire is the main cause of haze, and within the Asian region, this is known as transboundary haze, where in 1995 it causes a total shutdown within the region. Especially now with the climate change, it is important to stop fire from happening. It is the top priority of this research because early detection and suppression of fire is the only way to minimize the damage and losses. Peat fire causes haze and result in air pollution, which can actually give a negative impact on economy, human health, environment and weather. When the quality of air deteriorates, it can cause various health problems. The research investigates the use of IoT by involving sensors to monitor the parameters in the mitigation of forest fire. If we stop peat forest fire from happening, this will also stop haze from happening. Peat catches fire easily with the right conditions. It can also go into the soil and travel underground, which are troublesome and dangerous for firefighters as it can surface anyway. When it burns, it can release a large amount of fine particulate and produce the most carcinogenic haze of any forest type. Under the main project, Network ASEAN Peatland Communities, NAPC, a 2-year project funded by NICT Japan, a collaboration with Malaysia, Indonesia, Japan and Brunei, this project started in June 2018, having members from University Putra Malaysia and Mimos Sdn Bhd from Malaysia, Institute Pertanian Bogor IPB and the Agency for the Assessment and Application of Technology BPPT from Indonesia, NICT Asia from Japan, and UTB University Technology Brunei from Brunei. Early 2019, the first Brunei NAPC dialogue session was held to discuss peatland matters with experts from within the region together with the respective stakeholders within the country. With these engagements, a better understanding of peatland and the danger it has if fire is not contained was discussed. A site visit was also done to identify the location and to understand how the solution will be adopted in Brunei Darussalam, in particularly Badas area in Belait district. The technology involves 2 main components in order to mitigate the peatland forest fire. First, the weather station, to monitor the rainfall, temperature, humidity and wind speeds as well as direction. While second, sensors to detect the ground environments. They are soil moisture, soil temperature and water level. The overall solution uses LoRa as the gateway to collect all the sensor details from the ground and be pushed to the cloud via this LoRa gateway.
In our project, we have LoRa mode here, which is connected with different sensor probes. This LoRa mode connected with different sensor probe send the data to the gateway using LoRa interface. Next, this gateway is sending all the information to the cloud using 4G interface. In the cloud part, we have ThinkPark platform, which stores all the data from our monitoring point location. Next, this ThinkPark platform is sending all the data to the Grafana platform. In between these 2 points, we make a conversion of the data, a kind of pre-processing of the data that we collected. This Grafana platform is allowing us to visualize all the data. On top of that, we have mobile phone application for visualizing all the data we collected from monitoring point location. All the solutions which we have just seen will be deployed at these 3 locations, which is 1, 2 and 4.
Our main equipment is the WASP mode plug and sense device sensor node. This sensor node has a rechargeable battery with capacity of 6,600 milliamps per hour, or it can be solar powered by a 6.7 volt solar panel. In this project, we have 3 main sensors to monitor the condition of the peatland soil. We have the soil and water temperature sensor. We have the soil moisture sensor and the water level sensor. In addition to the sensors that we have, we are also using the in-situ rugged Troll 200, which has to be integrated to the WASP mode plug and sense libellium sensor node. Eventually, all the data has to be collected and sent to the cloud.
Currently, in Brunei, the area around Badas and Sungai Bera has been identified for the deployment of the monitoring solution. Due to the coverage and the prone fire incidents around the area, 3 areas have been located. Approval was sought after from local authorities, with fences installed in the areas that are closer to the roadside to ensure safety of the equipment, while the control plot in Badas is left in its natural environment. Weather station and the gateway is placed in Masutera to ensure steady power and connectivity to the cloud. This project has brought in stakeholders from government and non-government sectors. The context matters has been provided by Royal Brunei Fire Rescue, Heart of Borneo, Justry and Forestry Department from the Ministry of Primary Resource and Tourism. While the connectivity has been supported and sponsored by AITI, Anyan for LoRa connection and DST for connection to the cloud. Progress to the project has been shared in a number of Brunei Shell joint venture meetings to create awareness of the adoptions of technology for the Peatland communities. The solution has been tested in-house and will soon be deployed at the identified plots once the area is secured. A dashboard on the collected data can be accessed via Grafana and soon will be connected to JGN server to be merged with the other 2 countries within the project scope. And access through mobile devices will also be made possible to all relevant stakeholders. NAPC has technological and social innovation, where the engagement to the Peatland communities is one of the deliverables in the network ASEAN Peatland communities to ensure the social impact to the identified stakeholders. The last task is to connect the data collected from the 3 countries in the dashboard created by NIMOS and supported by Japan to ensure the mitigation of Peatland identified areas can be achieved.